We're going to go over the last topic in chapter 3. It's really tying some of the things we've been doing in chapter 3 together. And remember, chapter 3 was about categorical data and displaying it and describing it. So the final type of chart we're going to be looking at is a segmented bar chart. And a segmented bar chart is the same as a pie chart, but obviously instead of a circle, it's going to be in bars. Each bar is treated as the whole, and then it's broken down into segments proportionally. So it's not to say it's a percentage, and it's not to say that each of the totals are the same, but it's a percentage of it. So let's take a quick look at this bar chart. We have the number of people alive and the number of people dead by percent. We know from previous examples that the numbers of alive and dead on the Titanic were not the same. So even though it says the picture shows them being the same height, it's by percent, not by numbers. So the colors are going to be what grouping they were in, first, second, third class, or crew. And you can quickly see, for instance, that out of the dead, percentage-wise, the crew had the biggest percent, almost equal to third class. It looks like the crew is around 45%, right? So we have 45%, but the issue is, well, what is, if this is 45%, what is the third class? So third class, if we said this is 45%, let's just say this is 80%, right? So in fact, the third class was over only 35%. So we were correct in saying that the dead percentage, highest percentage was crew. So you really have to, after the first bar, you do have to then go and category, you do have to go and you have to do the math on the rest of them to be certain. You know, for instance, is the second bigger in dead or is it bigger in alive? It looks like it's bigger in alive, but I would quickly do some numbers. Maybe this is 55, maybe this is a little over 70, so we're around 16 maybe, let's just say. Versus this is from 80 all the way to 91, which is more like 11%, okay? So let's do some on our own. I'm going to have some questions for you. Take a look at this question and then answer the question on Edpuzzle. Okay, the percent of those surveyed from the Northeast who prefer country music is, when you go to the Northeast and you go to country, we're dealing with 50% to around 70%, right? This is around 70%-ish. So it's around 20%. Which is this number right here. Okay, let's go on to the next question. Take a look at this. Answered in Edpuzzle. Let me move this for you, if I can, hide it. Okay. Answer the question, and we'll come back to it. Okay, so we can go through, we're looking for the greatest, the percentage of those in the Northeast who prefer classical. The Northeast with classical, it looks to be roughly around 70 to 100. So I'd say that's a 30%. For this particular problem, we do have to go through each of them individually and look at the answers and then compare them. The percentage of those in the West who prefer country. So if we say the West is starting around 40% maybe, and going up to, let's just say 80%, the numbers, whenever they're giving us these types of questions, percent would be 40%. It's going to be clear that one's going to be bigger than the other. It's not going to be 30 and 31. It's going to be clear that we can do the math on it. The percent of the South who prefer pop or rock, well, this one's easy. It looks like it's going up to around 25%. So this is 25%. All the above are equal. That is not true. And finally, it is impossible to determine the answer without knowing the actual number of people. If they had asked how many people, then no, we would not be able to answer it. But all of these are saying percents. So therefore, we can answer it. So this is also wrong. So the correct answer here is B. Okay. So what can go wrong here? Let's talk about this picture here for a minute. This is violating the area principle. When I'm quickly looking at this this graph, it looks as though the one on the left, from my standpoint, it looks as though third class to me seems bigger. It just seems it to me. My eyes are seeing that it looks bigger. But when we put it down flat, we can see that the crew is the biggest. So even though the one on the left looks really cute, looks really cool, I actually used to do this as well when I was doing reports for my bosses at Bloomberg. It looks really nice. The one on the right is more obvious to see. Some people might like the pie chart on the left better. It's harder to compare fractions when we just have it flat. So just be careful with that. Next. Keep it honest. Make sure your display shows what it says it shows. So let's see what's happening here. Percentage of high school students who engage in dangerous behaviors. We have 27% use marijuana, 31.5% are heavy drinkers, and 50% use alcohol. What's wrong with this this pie chart? Yeah, so we have heavy drinking and we have alcohol. So this could have said something like, is moderate drinkers or light drinkers, or this, they would have to put the two together because using alcohol and heavy drinking overlap. Just be careful with the sounding of percentages. We went over this already in the previous lessons, but when we have examples where the wording looks so similar, you have to be conscious of the fact of what's different. The first example I have here, percentage of passengers who were both first class and survived, we would focus on first class and surviving the both, one that little box. But when we're talking about question 2 and 3, the percentage of first class passengers who survived, we would go to first class passengers, 325 as the denominator, and the numerator would be surviving and first class, which would be 203. So 203 divided by 325. 203 divided by 325. And the percentage of survivors who were first class, that one will be survivors would be alive, 711, who were first class, 203. Okay, so they're very different. And of course, our math would be very different as well. Be sure there's enough individuals. This is a kind of a funny little thing. We found that 66% of the rats improved their performance with their training. The other rat died. That means there were only 3 rats in the experiment. So just be careful of this. And this is where I think with COVID, they were having some problems with people saying that some of the different ways that they were trying to treat it were working. Well, they had a very, very small sample. It doesn't mean it wasn't working. It just means that it's a very small sample. And you may have to do bigger samples, which is what they're trying to do now, of course. The last thing I want to just mention is something called Simpson's paradox. Be careful when you average one variable across different levels of the second variable. This guy Simpson created or realized that there was a paradox when we're looking at data across different variables. So let's take a look at this. We have Mo and we have Jill, and they are pilots, and they fly in the daytime and at night, and we're being given their on-time flights across, let's just say a month or a year. I don't know what it is, right? So we have Mo that during the day was on time 90 out of the 100 times. Jill was on time 19 out of 20. That's very good. She actually did a little better than during the day. At night, Mo was on time 10 out of 20, and Jill was on time 75 out of 100. But when we go to the overall, it looks as though Mo did better. He got 100 out of 120 on time, and Jill was 94 out of 120. Now, interesting, both of them have the same number of flights. So how did it happen that Jill looks like she has worse performance than Mo? And it is because of the fact that while Jill had a much higher percentage of daytime on-time flights, the nighttime flights, while she was still higher, she had less on time, and that makes sense because it's at night. The numbers aren't the same in each category. So she had bigger percentage, of course, at night, bigger percentage, of course, in day, but when you add them together, the overall becomes looking like it's not right. So just be careful. That's called Simpson's paradox. I haven't seen it on any APs. However, I could see that being something interesting you could talk about if needed. Have a great day.